Steve, would you mind starting in on
Oh,
your
yeah,
talk?
no,
And
not at
I'll
all.
introduce you because I kind of just had you speak without telling everybody who you were. So,
Sure.
Steve is here. He's joining us. He's a mechanical engineer and he's actually in the medical device industry with over 17 years of experience. He was born and raised in Santa Cruz. He attended Santa Cruz High. He went to Cabrillo, just like all of you, and then transferred to San Jose State. And he now works in the field of structural heart at OChem Labs in Santa Cruz. Welcome, Steve. Thank you
Yeah,
so much for being here.
thank you, Priti. Appreciate the introduction. Yeah, so I guess I can start by sharing my little deck that I have. And I guess we'll go like this. Does that come through full screen for everybody?
Yes, I
Yeah.
can see it.
Okay. Yeah, so this is a deck I've actually used for presentations like this in the past, where I spoke to an engineering class, um, and I'll try to just walk through some of my experience and mainly my experience from Cabrillo through the early part of my career, and then like a little bit on my current where I'm currently at, and I want to leave a lot of time for questions. So feel free to like interrupt me at any point during the presentation and ask a question about something in particular. So I'd rather it be more conversational than me just presenting a bunch of stuff on slides. So um, let's see. Oh yeah. So these were the stock questions that Preeti sent me before. I grew up in Santa Cruz. How did I decide on my major, or how did I decide on engineering in particular, my major, which was mechanical engineering? So I grew up in a really hands-on household. My dad was a design engineer. He didn't have a college education. I mean, he had taken some college classes early in his young adulthood, but he didn't have a formal engineering degree. But he worked as a design engineer in the semiconductor and defense industry for a long time. So it was a really hands-on household, always wrenching on stuff, cars and building house and things like that. When I first graduated from high school and started going to Cabrillo, I thought I would go into computer science or computer engineering because I was really hands-on with computers in high school. And I took a few programming classes and kind of decided it wasn't for me. And after consulting like with my dad and with Karen Groppi and Joanne Pinzardi, decided on mechanical engineering. And that's mainly the industry my dad worked into. So, I consulted with him. My experience at Cabrillo was really positive. It was a great spot for me to experiment, with computer science and computer engineering. Um, and it was local and the price was right. And, the staff and faculty were always really supportive. And the class sizes were very advantageous. So I had a really positive experience, and it allowed me to kind of discover like what was the best fit for me. When it came time to transfer, I felt like that was very, very seamless. I don't know what the process is now, but um, during the time when I transferred, it was a guaranteed transfer process if I satisfied the requirements, which I had.
Mm-hmm.
And San Jose State was also a very supportive environment with really good class sizes and collaborative faculty, but part of a larger administrative system, definitely. Just admissions, and the College of Engineering and everything it's just a larger system. So it was a little bit more difficult to get things done and get people's time, but overall it was also a very positive educational experience at San Jose State. Um, my career and some of my favorite projects. I'll talk a little bit about my projects and the ones like I decided to include in the presentation, but um, like my career has been predominantly focused on medical device. So I started very early when I was still attending San Jose State, interning for a molecular diagnostics company that makes PCR based tests. We all know the term PCR now, thanks to COVID, but the company made these prepackaged tests at the time to test for flu and anthrax and cancer and HIV and a lot of other things. They didn't make a COVID product in 2007, but they eventually did. So I started out there, and that kind of set the course for my medical device career. After that, through connections, I got jobs with various organizations that made, instead of in vitro diagnostics, my experience since then has been more focused on in vivo devices for delivering a therapy or performing some sort of diagnostic. So I don't want to
Could
get
you,
lost.
I'm sorry to
Yeah.
interrupt, Steve, but could you tell us what in vivo means?
Yeah, in vivo is a Latin term meaning like inside the body, right?
Okay.
Yeah, yeah.
Yeah.
In vitro means outside the body, and in vivo
Oh,
means inside the body.
okay.
So I use that term to differentiate from in vitro, because in vitro, in vitro fertilization, right, would
Yeah.
be in one term that some of us might be familiar with. So fertilization happening outside the body. And in vivo, yeah, just refers to something happening inside the body. So since my experience at that molecular diagnostic company, all of my experience since then has been with different devices to either give it a diagnostic, tell the user something about what's going on inside the body, or to deliver some sort of therapy, to like do something to fix a problem inside the human body. And so far it's been like a really positive experience. Most of it has been with small companies that have to move very quickly to design and iterate and come up with a solution and get to market, because they have no income coming in and they're living on credit, and they just need to show progress and get data, human data, so that they can then move on to the next step. My engineering degree impacted my life. How has it impacted my life, my quality of life? It's had like a very positive impact. So my educational background has given me a lot of career opportunities, a lot of mobility in the industry. Again, I majored in mechanical engineering, and it's just given me a lot of mobility, and it's also given me like the formal depth of knowledge to complement my engineering intuition when it comes to doing my job. And I rely on that heavily, both my intuition and on that formal education. Because day to day, there's problem solving activities that I'm a part of, and having that formal background in mechanical engineering certainly serves to add authority and obviously logic, to my problem solving. It's also given me a fairly comfortable life in the Bay Area, and the opportunities to move from one company to another in pursuit of a better opportunity. So I'd say that's had a very positive impact. And another positive impact is that I'm just exposed to really smart people who are problem solving oriented, and they have good ideas, and they inspire me to think harder and to come up with better ideas. And that's just kind of a self-serving cycle of innovation. And also the impact to the public. I've seen direct application of the technology to real people, and it feels good, to work on something that can have a positive impact on people. So like overall, it's had my decision to study mechanical engineering, going to med device, has had a very positive impact. And if I had one suggestion to engineering students in their educational and career, it would be to get an internship or volunteer as early as you can. Like as soon as you're able and stable in your life, a balance of academics and finances and everything and free time, try to get involved with in the field that you think you want to work in, so that you can begin to develop the skills, communication skills, and that what we call like free form or boundless engineering problem solving, which is very different than the academic environment. And also really just to figure out if it's for you. I went to college at San Jose State with people who studied mechanical engineering, and then they never went on to work in that industry. They decided to take totally different paths in their career. So It's not to say it was a waste of time, but you know, it's good to find out as early as possible if it's what you really want to do. So maybe I'll take some questions and try to look at the chat here.
Yeah, there's a few in the chat.
Okay.
Um,
So I'm seeing, what was the hardest part of transitioning from studying computer science to mechanical engineering? See if I can just start it. I'll start at the top. So cool. Medical device field is filled with Latin terms. Oh, did I learn Latin or take a course on Latin during my education? No, I did not. It's all just on the job training, looking it up on the internet, basically. So Latin is a dead language outside of the classics literature and the medical industry and zoology, I guess. Yeah, in medical terminology, a lot of Latin terminology is used. So it's something you get a good atlas of the human body, and you just use that to educate yourself on the area. How was the extracurricular experience at SJSU? Did I feel the institution gave plenty of opportunity for internships, co-ops, and other hands-on experience like project? I think that during my time, there could have been a little more support by San Jose State in helping the students get that, but the opportunities are there. You need to kind of bang the boards and go to the student union and look for entry level. There are entry level postings for internships and all that as part of the ecosystem of San Jose State. But you do need to be proactive about it. You know, just showing up to your statics class or your dynamics class, your professor is not going to talk about an internship. So if you are interested in an internship or like working for one of your professors, that's something you need to step up and ask for. But there are hands-on projects, definitely, and clubs that perform a lot of really advanced, especially in the automotive space. There's a lot of really hands-on and student-driven projects that are really exciting. So the opportunities are there, and they're competitive even on the national level in those projects and in those clubs. So if you want that hands-on standalone experience of a project in a club, San Jose State does offer those opportunities.
I'm going to interrupt you for 1 minute,
Sure.
Steve. And I'm just going to remind you all that on that engineering student list, they've been posting a lot about internships and getting internships this summer and opportunities. So if you haven't accepted the engineering Canvas page list yet, please do that, because that's where Cabrillo is really active in posting stuff that's available. Okay,
Yeah.
next question, Steve.
Next question. What was the hardest part of transitioning from studying computer science to mechanical engineering? I'd say that I can't really speak to the hardest part because computer science I found pretty difficult, programming. Yeah, I think just being behind by however much time that I had decided to commit to computer science rather than mechanical engineering. That was the hardest part, kind of losing that time. But you know, the courses are hard no matter how you slice it. So it's engineering.
There's a bunch of questions again on internships. Tips on finding internships. Did you do an internship? What was your first internship? And what age did you start internships or volunteering if you did either?
Yeah, so I started, I'll start from the end and move back. I started interning in my junior year, basically my second to last year at San Jose State. I got the internship through a classmate. His uncle was the vice president of engineering at the company. So personal connection, you know, discussing opportunities. I would advise, you know, going to companies' websites and looking for opportunities for summer internships. All the larger organizations, everybody from NVIDIA through, if you want to talk about medical device, Abbott Vascular, they all have internship programs, like nationally structured internship programs. If you want to work for a smaller company, then find that company or find the industry and find smaller companies that are operating in that space, and just go directly to their website, send them an email, and tell them that you're interested in an internship. Send them your resume and a little bit about yourself and why you're passionate about what they're doing. Yeah, so really just putting yourself out there and and trying to stand out from the mechanism, the algorithm that essentially analyzes your resume when you upload it to a website. If you have a personal connection, or if you can find the hiring manager on LinkedIn, send them a direct message. If you don't have a LinkedIn profile, make one. It's a necessary tool, I think, for networking in the professional environment. So make a LinkedIn and put pertinent experience on there so that you have a way to start that communication track.
If I could ask you a question just
Sure.
on how did you get into medical devices? Was that through an internship? Was it your first job? How did
Yeah.
you make the
Yeah.
leap from straight pure mechanical to medical devices?
Yeah. So the first internship I got when I was second to last year at San Jose State. I actually, before that, I put my resume on Craigslist in job postings. And I put my resume there, and I a little blurb about what I was looking for. And an alumni from Santa Clara University who was starting a company reached out to me about being their gopher, in the shop. So doing, various tasks around the shop and around the company. So that was my first opportunity. The first like real opportunity was with this molecular diagnostic company. It lasted for 2 years through the summer and part-time during the school year. And I got that interview and that opportunity through a classmate at San Jose State.
Okay.
After that, all the jobs that I've gotten have mostly been through professional connections. Yeah.
Okay, lots of questions. But did you have more slides, and do you want to come back to
Yeah,
these?
I can. I'll go to my next slide, and then I'll come back and I'll answer questions. So the last question I left off with at 427, Kate Ferenc. Okay, I'll come back to the questions.
Okay.
So some of the projects I worked on, I didn't put any words on this slide so that I can just talk to them instead. So these are some of the projects that I've personally worked on. They have been all over the place as far as the kind of technology and the area of the body where they were intended to be used. So if we start like in the upper left, this device was an implant in the abdominal cavity. So outside, of your organs, outside of your lungs, but just in the space in your abdominal cavity. And it was actually a water balloon, for all intents and purposes, that was attached to the inside of the abdominal wall. And it was designed to occupy the space that your stomach would expand into when you eat food. So this was a treatment for morbid obesity. And it was an appetite suppressant of sorts. So it would prevent your stomach from swelling and give you that feeling of satiety or fullness earlier in your meal. And it was designed to treat morbid obesity, as I said. So, I was an early engineer, or a kind of a low-level engineer, junior engineer, working on designs of the mechanisms for delivering the implant and for attaching it to the abdominal wall on the inside of your abdomen. Down here in the lower left, there's kind of a little picture in the very lower left of looks like a shaft with a bunch of color on it. This is a catheter that would be inserted into your venous or arterial system and traverse all the way up into your heart, into one of the chambers of your heart. And from there, it would be used to, it sounds terrible, but electrocute, to burn discrete sections of the chambers of your heart to destroy the ability for electrical impulses to get to that area of the heart. It's called electroablation or electrophysiology, where they selectively kind of kill the nerve endings to different areas of your heart in an attempt to rebalance your heart. So if you have a heart arrhythmia, or what's called AFib, or atrial fibrillation, it means that the synchronization of the chambers of your heart and when they beat is off. And in an effort to reestablish that balance, they will kind of kill the communication method between that node in your heart that sends electrical impulses. They'll kill the communication method to that area of the heart very selectively, very small areas, and try to rebalance the communication in your heart. Here with the big A and the Abbott was another catheter product that I worked on that was again inserted into your femoral artery, goes all the way up over your aorta and in through the aortic valve of the patient's heart. And it's actually a pump, an impeller pump that would pump blood out of the left ventricle into the aorta. And what this would do is it would kind of unload the heart and give the patient's heart some relief, so that the heart could heal, and also so that the physicians could carry out some other operation on the heart, which was kind of taxing. So they wanted a device that could provide what they call mechanical circulatory support to the heart. In the lower right, this is an implant designed to go in between of the vertebrae of a patient's back. Degenerative disc disease is when the discs, the soft pliable discs between the vertebrae and your back kind of get crunched and squished, and they never heal on their own. So one of the treatments is to put a spacer in between of them to reestablish the height between the vertebrae, and then to stabilize the vertebrae with screws and plates. So this cage went in small, and then we had an expanding mechanism inside that then kind of jacked it up to a bigger size. Let's see, here in the middle is the project that I'm kind of currently working on. These are all the competitor products. I can't show you our product because it's super squirrel secret, but these are all kind of the competitor products in the space. And basically what I'm working on are delivery systems and implants for the valves of the heart. So we have 4 valves in our heart, and as we age and our diet is not so great, or if we're smokers or drink too much, those valves, they don't work as well. They get stiff, and then the mechanism of the valve doesn't work as well, and then our heart gets unhealthy from there. So these artificial valves are implanted to kind of reestablish the function of the valve in the heart. And the kicker here is that these products are designed to be implanted inside the heart through a major vessel. So through your femoral artery or your femoral vein, a catheter travels all the way up to the heart and then deploys the valve inside the heart. So there's no open heart surgery, and the patient's heart is never stopped. And the heart is beating the entire time. The patient doesn't have to go on a heart and lung machine. That's very traumatic for a patient. So it's just traumatic to the heart to stop it and dissect it and open it up and put a new valve in. So these valves are all put in what they call percutaneously, which just means through the skin into a vessel and then delivered there. So, all right, I see there's a lot of chat, so I'll try and take some more pictures. What project did I enjoy working on the most? I would say my current opportunity is at Occam Labs is the one I enjoy the most. Just the content is just kind of space age, trying to do this in a minimally invasive way, put a new heart valve inside somebody's beating heart. It just sounds like science fiction, and it kind of feels like science fiction sometimes. So, and the people I work with are really smart and nice. So I'd say the current opportunity. How often do I converse with doctors and surgeons? So in my current role, not as much as I have in the past, but the R&D engineers work very closely with surgeons. So we have advising members of our organization. They speak with them all the time. We have clinical engineers who are engineers who directly interface with doctors all the time. They're responsible for training the doctors on the procedure. So clinical engineering and R&D engineering, there's a lot of interaction with surgeons. I would say, probably 5 to 10 times a year. Let me see if I can go back here and some of these other
Brandon had his hand up earlier, so he has the last question in the chat. If the
Okay.
device takes up more space in your stomach, is used to satisfy hunger, then if you would take it out immediately, would it go back to being less satisfied after a meal, or is there a slow process that lets the stomach regulate to normal size?
Yeah, so our anatomy doesn't like respond immediately to this kind of stuff. So yeah, if you were to take the implant away, there'd be a period of time where the stomach would expand back to its like normal size. Um, and that's actually one of the downfalls of the competing processes. So we've all probably heard of gastric bypass surgery, and that's where they actually go in and they dissect your anatomy and they reroute your stomach and kind of segregate off a section of your stomach. Even in gastric bypass, the stomach that they leave behind, the volume that they leave behind, a smaller volume, it expands over time. So our anatomy has a very powerful ability of like remodeling. They actually call it remodeling. And it will remodel over foreign bodies that we put inside the body, foreign material. So that's a big challenge in medical devices, coming up with designs and materials that will not be rejected by the body and that the body cannot remodel around and kind of defeat the mechanism of action. So yeah, in answer to your question, in short, if you were to take it away or deflate it, then the stomach would expand again. So it was planned to be a potentially lifelong type of implant for the patient. Yeah.
Okay. Yeah.
How often? Let's see. Whenever you work on things, do you always have to hide what you're working on? Not always. If the core technology is kind of out in the public space, then you're kind of free to talk about it. If you work in development, in research and development at an organization, whether it's medical device or tech or cars or spacecraft, there's always going to be an element of what you're working on that is private. And that's because what you're working on eventually ideally will give your company a competitive advantage against the competitors. And so you don't want to discuss that early work, that early stage research and development work, like publicly, especially among members of your professional sphere, because yeah, secrets get out, and that's usually how they get out, is by people talking about them. This project seemed crazy. What's the craziest project I think I've worked on? It would definitely be the current one. The current project is by far the craziest. Deploying a new valve inside somebody's beating heart has just like so many complications and so many things to consider from a design perspective, from a processing perspective, and from a procedural perspective, that it's by far the craziest. And I will let one thing slip. One division of Occam is actually working on a semi-robotic platform to deliver the valve. And that's because a user, turning knobs and moving handles in a fully mechanical system is not the most advantageous for these types of procedures. So a team within Occam is working on a electromechanical platform that's piloted with an Xbox controller, and the user, pushes buttons and moves the knobs on the Xbox controller, which control a robotic platform, which delivers the valve, pilots the catheter through the chambers of the heart and delivers the valve. So, there's medical device engineering, electrical engineering, mechanical engineering, user interface, from a software standpoint, from a mechanical standpoint. It's got everything. It's by far the craziest. And I am working with Cabrillo to try to get a tour of the facility, to have you all come. So I think we're going to try and do that at some point.
That would be awesome, Steve.
Yeah. Somebody has a ventral septal defect.
Yeah, defect in his heart. How would an implant for that look? Have you
Yeah,
designed?
so there is have I designed any for that purpose? There's actually quite a few types of implants for these types of defects. So anytime you refer to septal, In the heart, that's usually the wall that separates the atriums or the ventricles. And some people are born with defects in those septums, which allows blood to pass between those chambers when it shouldn't. And so most of those implants to correct that, minimally invasive, would be something that fills the space and then promotes tissue growth to fill the hole. The challenge would be accessing that defect in a minimally invasive manner, through a vein or through an artery. That would probably be the major challenge there. But I'm sure there are probably solutions from an open heart perspective, and that's something for a patient with that to think about, is when the best time to address that. Talking to your doctor and stuff. So. Medical field is precise with such high stakes. Do I ever feel fearful working on projects that essentially put someone's life in your hands? How do you deal with this anxiety? Like, you kind of need to set it a little bit of apart, like the same way a doctor would kind of set, the person's individuality apart when they're having to work on them. But also the canons of engineering. The canons of engineering are to like do the right thing, essentially, even when nobody is watching. And I think as long as you do that, and you, in a true spirit, like collect the data and follow the data, then I know my anxiety is kind of put to rest, in that, knowing that I tried the hardest to prove out a design or to prove out a process as far as I could potentially imagine. That helps to put a lot of those jitters to rest. And testing, we just test a lot. So we test on the bench. We do test in animals, live animals, who are sacrificed at the end of the procedure, so that we can investigate the efficacy of the procedure, of the device. So yeah, test animals pay the ultimate price for the development of this type of technology. And it's not taken lightly. Those facilities are not like they are on TV or in the movies. The animals are very well cared for, and they're held to very high standards as far as morality and cleanliness and procedures. So they're regulated by the FDA, or by the USDA, actually. So yeah, so a lot of testing and a lot of homework, just really trying to prove out that you did it right.
Steve, I'm going to interrupt you.
Yeah.
So what was your exposure to biology classes before you went into this field?
Yeah, I never took a
Any
biology
of life
class.
science?
Yeah, I took a chemistry class at Cabrillo, and I took one biomechanical class at San Jose State as an elective, a technical elective. But I never took formally any biology training or a biology class. So my understanding of the biology of the technology that I've worked on, or that the technology was applicable to, just came from on-the-job education.
Great. Our next speaker is here. So did you have some final words for our class?
No final words. Just yeah, I mean, if you're interested in it, I can Preeti, you're more than welcome to share my email address with the class. Okay. And I would encourage you all to reach out to me if you have any further questions. And yeah, definitely look for internship opportunities as early as possible, even volunteer opportunities. I know that's hard to do and not get compensated, but just exposure to the industry that you're interested in will help you make a lot of decisions. So.
Thank you so much for joining us, Steve, and telling us all about this and being here early.
Sure. My pleasure. Yeah, thank you so much.
It worked out really good. Yeah. All right. Well, have a great evening, and we'll be in touch.